You know what hurts more than a power outage? When you spend a fortune on backup power, and the moment it happens, the inverter trips, the lights flicker like a horror movie, the batteries scream, and your backup becomes a very expensive ornament. And the scary part? Most failures aren't because the inverter is bad quality. They happen because of wiring mistakes, small ones, that quietly build up until something fails, overheats or trips, or even that we do not understand the backup power installation correctly. Today I'm going to show you the biggest wiring mistakes that cause backup power systems to fail in South African homes, and how to spot them before they cost you thousands. And yes, there's links back to SANS wiring rules and certificates of compliance realities. The stuff nobody explains properly. A quick one. If you've ever had your inverter trip or your lights behave weird during load shedding, drop a comment saying trip and tell me what backup you've got, inverter size and battery size. I'll read those. This is not a how to wire it yourself video. Electricity can kill. Fires don't give warnings. This is a homeowner's awareness guide, so you can ask better questions, spot red flags, and stop paying for nonsense. Also, if you want more South African electrical content, straight talk, no fluff, hit subscribe now, because load shedding isn't leaving, and neither are the cowboys or the fly-by-nights. In South African, backup power has become emotional. People aren't buying a solar or inverter system because it's trendy. They're buying it because they are tired of no Wi-Fi, no alarm, no gate motor, spoiled food, and sitting in the dark feeling unsafe. So they panic. And they panic buy a system and install becomes erased. Please just make it work today. That's exactly when mistakes get baked into your home. And SANS is very clear on one big idea. Safe wiring isn't optional, especially when a property is sold or a new tenant moves in. Then the certificate of compliance must reflect compliant work. And please, SANS is not somebody's brainchild or a money-making scheme. It is there to protect you and your family. Mistake number 1, no proper changeover or illegal backfeed. This is the king of failures and the king of danger. If your backup power is connected in a way that can feed back into the supply side, whether municipal, prepaid or generator input, then you're sitting with a time bomb. If your system has been approved by the relevant supplier, it is legal and correctly installed. But if you feed back just because your meter can run backwards, it's not legal, neither is it safe. Should you feed back and an accident happens when the utility supplier works on the power system, they can trace it back to you. And then you are in big trouble. Why it causes failures? The system sees weird reference points and trips. Protection doesn't behave correctly. And you get nuisance faults and trips. And you can damage your equipment. Why it's dangerous? It can energize circuits that people assume are dead. It can put voltage where it shouldn't be, and it can put lives at risk. What you want instead is a proper, compliant method of changeover, isolation, installed by someone who understands SANS requirements, not a plan. If you want, comment changeover, and tell me if your system is an inverter with essential dB, a generator, or I'm not sure. I'll tell you the questions you must ask your installer. Mistake number 2 is the wrong circuit breaker size, and this one destroys wiring quietly. This one comes straight from your SANS-based house checklist document. On a plug circuit, the circuit breaker rating must not exceed 20 amps, and on your light circuit it may not exceed 16 amps. And you'd be shocked how many old homes have 30 amp plug circuits. Totally wrong for modern COC expectations. because the socket outlet is not designed for that kind of load. It will malfunction. Now here's how backup power makes it worse. When people add an inverter or essential plugs, they often change the circuit breaker, move circuits, add a sub-dB or repurpose existing wiring. And then they slap a breaker on it because it keeps tripping otherwise. That is not fixing the problem. That is removing the warning light. Because wiring fails from heat over times. Not always a big bang. Sometimes a slow, silent cook in the ceiling. If you've ever heard someone say, we just upside the breaker so it stopped tripping. Nope. That's a massive red flag. Mistake number 3. Neutral and earth mistakes. That's the ghost faults. Backup power failures love neutral earth mistakes because the systems are confusing. Random tripping, lights glowing faintly, appliances acting possessed like it's a ghost playing around inverter. Error codes that come and go. If your certificate of compliance visual checklist docs, one practical test was mentioned. When you trip the earth leakage, plugs geyser underfloor heating and your pool should go dead. That's not just nice to have. It's a sign the protection and the separation are behaving correctly. With backup systems, common neutral earth mistakes include mixing neutrals from different sections, incorrect bonding arrangements, or messy terminations that look okay, but it isn't. This is also where the cheap installs really show. Neutrals not really managed, no clear labeling, and nothing makes sense when fault finding starts. And you know what that means? You pay for callouts over and over again because nobody can diagnose it quickly. In my experience through the years, I have realized that to rewire the entire system is nearly always the best option. You spend less time doing the fault-finding process and the client does not feel fed up with your competency. To start fault-finding, you have to think like the cowboy who installed it, and that is a huge challenge, ask me. Want a simple homeowner-friendly what to check in the DB list? Comment, checklist, and I'll format one for you in the next video. Mistake number 4. Poor DB labeling and unfinished openings. DB labeling must be proper, not scribbled nonsense. Old labeling must be removed and openings to live parts must be properly closed. Not tape, not a piece of plastic shoved in there. A legal closure should require a tool to open it. Now here's why this matters for backup power. Backup power adds complexity. Essential circuits, non-essential circuits, inverter supply, surge protection, changeover, it's not labeled and closed properly. 2 things happen. People make mistakes during emergencies and in load shedding, and that's an emergency vibe. And fault finding becomes expensive because nobody can tell what feeds what. This is how you get mystery trips. And the inverter is broken arguments when it's actually sloppy installation work. If you ever opened a DB and thought, yeah, I don't know what to touch, what to do with this, hit like. That's the exact feeling this channel is here to fix. Mistake number 5. Undersized cables and long runs is a voltage drop. This is the silent killer of backup systems. Backup power often feeds lights, plugs, routers, alarms, gate motors, electric fences, cameras, etc. But the inverter is sensitive. If the wiring is undersized or the run is long, you can get a voltage drop, higher current draw, overheating, nuisance trips, and sudden shutdowns under load. And the worst part, it might not only fail when you need it most, it must be designed around real needs from the very beginning. If you want, tell me in the comments what you run during load shedding. Lights, Wi-Fi, TV? Or are you trying to run kettles, air fryers, microwaves, and the whole street? No judgment, just reality. Mistake number 6, the earth leakage issues that people ignore. Missing earth leakage, earth leakage that won't trip on test, or earth leakage with open spaces around because of mismatched part. With backup power, earth leakage becomes even more important because you're switching sources. Circuits get split and protection must still behave correctly. If the earth leakage test button doesn't trip, don't argue, don't negotiate, fix it, replace it. Because when something goes wrong, earth leakage is one of the layers that stops you from becoming the path to earth. Do me a favor, please. This week, press your earth leakage test button, then comment, tripped or didn't trip. And if it didn't trip, stop ignoring it, please. It's your safety. Outdoor external points not protected. From rain, it's chaos. Outside plugs and switches must be protected from rain, splashing. Visible outside cables should be in conduit. No loose cables lying around, unless it's the correct type. If you experience trips only during rain, it means that something gets wet when it rains. Or if something trips every night when it becomes dark, it might be the day-night switch, which is faulty. During load shedding, outdoor equipment becomes more important. Electric fences, gate motors, CCTV, beams, garage doors. And what happens? People run temporary feeds or extension leads just for now. Connections, and then it becomes permanent connections. Rain gets in, corrosion starts, then the system starts tripping randomly. And everybody blames the inverter or the installer. No, water and bad external work kill systems. If you want a video specifically on electric fence and gate motors and backup power, the right way to think about it, comment security. I'll make a plan for you. The dodgy guy explanation is the biggest red flag of all. Example, I've seen again and again a homeowner ask a valid question like, where's the COC? Is this SANS compliant? Why is there tape over that opening? Why is this breaker bigger than what it should be? And the installer gives a long story. No, don't worry. Everyone does it. SANS is only for big companies. That's rubbish, man. That's just paperwork. The inspector won't check that. That's not confidence. That's a sales pitch. A proper electrician doesn't get defensive. They explain, they reference standards, and they document the work properly. No paperwork, no scope of work, no SANS references, no COC plan. Backup power is not just a product, it's an alteration to an electrical installation. If you're paying for backup power work, you should be able to ask, what exactly was changed? What circuits are essential? Where is it labeled? What protection was added? What is the COC plan? And a solid contractor can give you a scope of work with SANS references to faults or repairs. That's one of the strongest filters for fly-by-night versus professional. So let's land this plane. Backup power failures are usually not bad luck. They're predictable results of wrong breakers, bad neutrals in earth, sloppy DB work, poor labeling, and closures unsafe, changeover setups, and installs done in panic. If you want your backup power to be boring in the best way, it needs to be safe, neat, compliant, and properly installed. If this helped, hit the like button to YouTube so that YouTube can show South Africans who are about to get robbed by bad installs. And drop a comment with what backup power you have and what it's doing wrong, because your comment might become the next video. I'm Stephen. I will see you in the next one. Thank you.